Hey guys, welcome to Exceptions in the Equation of a Straight Line instructional video. Which of the following equations correctly defines the line shown in the graph below? So sometimes, usually, I should say more frequently, we get lines that have what we call a slope or a rate of change. And we've seen lines that look like my pencil here that are growing lines, whether they have an initial value way down here and whether they're very steep or they're very flat, or whether the initial value is up here somewhere and they're very flat or really, really, really steep, whether they're positive or whether they're negative. If you imagine this is a ski hill, that would be pretty terrifying. That would be pretty boring, right? But certainly either way, they're sloping down, negative slopes. Sometimes, though, we get equations that look different. And the first thing you should notice about this line, the gray line that's now underneath my pencil, is that it is a perfectly horizontal line. That line never changes. And you'll remember from the video that you just watched that when you see a perfectly horizontal line, really the simplest thing to remember is that the y is always equal to some number. And if you look at the graph, since we're going up by ones, you can see here that the y value, no matter where we are on this line, is always equal to 2. So a nice way of thinking about this is, if you look at this point here, for example, this is the point 0, 2. So the x is 0, the y is 2. And over here we have the point negative 5, 2. Right? So the x has changed. It's no longer 0, it's negative 5. We've gone to the left. But we haven't gone up and we haven't gone down. The y has not changed. Negative 4, 2. Negative 3, 2, negative 2, 2, negative 1, 2. Here's 1, 2. Here's 2, 2. Over here we've got 3, 2, 4, 2, 5, 2, 6, 2, etc. We can keep going. X's can keep getting bigger and bigger and bigger, and Y's and X's over here can keep getting smaller and smaller and smaller, but the Y will constantly be 2. Okay, so this is called the constant function, actually. And basically, if you see a horizontal line, that's your answer. The one that they're trying to trick you with, we'll look at some of these other ones and what these ones look like later on. But basically, horizontal line is always going to be y is equal to some number. Keyword there being horizontal is always going to be y is equal to c, if you want, for a constant, or some people like to write y is equal to some number. Whatever you need to write in your notes so that you remember that particular type of line. Hey guys, welcome to Exceptions in the Straight Line. Which of the following equations correctly defines the line shown in the graph below? So the interesting thing about this line is that at first glance you can see it has a slope, but you might notice that its initial value is located right there at the origin, which means that the b is equal to 0 for this line. So a couple of things. So if we're looking at which of these equations this might be, you can rule out a right away because a has a very clear initial value, right? Y is equal to ax plus b. There's your b. It's done. We know the b can't be 2. That would be up here. This one looks a little weird. We could isolate y by dividing both sides by 2, and we get this one when we do that. And that looks like it's possible. We can come back and revisit. And over here, we've got x is equal to 2. I can tell you right away that that's not the answer, because in x is equal to 2, you'll remember from the videos, in x is equal to 2, the x is always a vertical line when we don't have a y. If there's no y in the equation at all, we get a vertical line. If it was y is equal to 2, we'd have a horizontal line at the y of 2, as we just saw in the last video. In this one, though, with the x, so basically I'm down to b and I'm down to d, and which one of these is accurate? Well, in order to calculate a rate of change, we need 2 points. And so I'm going to kind of look at my graph. I can see my 0, 0 here pretty clearly marked, and I'm going to kind of follow my line until I get a nice clean point and I get that point right there. And that's the point 1, 2. And now I can calculate a rate of change using 0, 0, and 1, 2. So if I come over here, a is equal to y2 minus y1 over x2 minus x1. So I'll call this x1, y1, and I'll call this x2, y2. And I'm going to get a is equal to 0 minus 2 over 0 minus 1, which is equal to negative 2 over negative 1, which is equal to 2 over 1, or 2. Negative divided by a negative is a positive. And so I have an a of 2, and the only one with an a of 2, careful, it looks like it's got an a of 2, but not when you divide both sides by 2, right? The a is actually a 1 here, it's hidden. This is the one that has the a of 2. So your answer is D. It's got no initial value. We could write plus 0 if you wanted to see the initial value in the equation. Y is equal to 2x plus b with a b of 0, which we see clearly marked on the graph.